It's 1881. It's the first International Polar Year. A dozen countries have gotten together to learn more about the Arctic region. This is the first time that science is being integrated into polar exploration. The United States is doing its part. They've established a base 500 miles from the North Pole. The officer in charge is Adolphus Greely. Greely and 24 men are dropped off by tall ship on the shores of the narrow passage between the northern tip of Canada and the northernmost tip of Greenland. Their mission is to go out and conduct science and also to fill in those blank spots on the map. This is actually Greely's very first time in the Arctic, and most of the men that he has with him. Well, they go out there and they accomplish a lot. But things start going sideways because no relief ships are able to get back to pick them up. Greely and his men are essentially abandoned up there. So at the end of the third summer, Greely is faced with this harrowing decision. Should I stay or should I go? He and his men load up 3 wooden rowboats and they head off. Much of their time is spent hauling those boats over a frozen ocean. Well, they make it to this prearranged rendezvous site that's about 300 nautical miles to the south. When they get there, they discover that nothing has been left there for them. And then comes the winter. By the following spring, when rescue finally does arrive, out of 24 men, there are 7 survivors. So 120 years later, I was asked to lead the first ever expedition to retrace Greely's journey. I told the man that had approached me, I said, nothing has changed since Greely's time. And it was true. The conditions that we encountered in 2004 mirrored those of the 1880s. The ice floes were so huge, that some of them were 50 feet thick and 25 miles wide. A single ice floe. Those floes were so big that some of them even blocked that channel, with one edge nudging up against Canada and the other nudging against Greenland. Fast. So like Greely, it took us 6 weeks to cover those 300 nautical miles. And unlike Greely, we got picked up at the other end. So in the years that followed, I spoke to a lot of people about the Arctic. And I came to realize that while many are familiar with the idea of melting ice caps and the retreat of polar glaciers, there are very few of my audiences that had any familiarity with the Arctic Ocean environment. And so in 2017, I made the decision to go back to the high Arctic to make a film about the Arctic Ocean and its sea ice. Well, I knew that things had changed up there, but being back was a complete shocker. It was as if all of those ice floes, those massive ice floes, had been run through an industrial blender. Gone were those massive floes, those Manhattan-sized floes of the past, and in their place was a rubble field of crumpled and battered sea ice. Some floes the size of this stage, others the size of this red circle. It was truly extraordinary. In 5 weeks of travel, we managed to cover 60 nautical miles. Our journey actually became one of survival. Well, these 3 snapshots in time are really important, and I want to come back to them. But I want to talk about the Earth for a moment. What if our Earth had a simple way to keep itself cool? A cooling system that ran all year long, always on automatic. It would let in just enough of the sun's energy to keep us comfortable, and it would deflect just enough of the sun's energy so that we didn't overheat. In the language of science fiction, it would be like some kind of planetary shield, or maybe a giant mirror, intercepting those solar rays and sending them back out to space. Well, our Earth does have a simple way to keep itself cool. The Arctic Ocean. It's barely visible on a wall map. And yet it's wide enough to swallow the moon. And when you find it there on that map, like all oceans on there, it's going to be represented in blue. Well, what if that ocean was actually white instead of blue? What if its surface was actually covered in frozen white ice? What would happen if the sun shone on a white surface instead of into a dark blue sea? Or to put it simply, why does the color of the Arctic Ocean matter? And how does that relate to this idea of a planetary cooling system? For millions of years, the surface of the Arctic Ocean has been mainly frozen into white ice. And because it's been frozen, it's been able to reflect the sun's energy back out to space. In fact, snow-covered sea ice reflects 93% of the incoming energy from the sun. And that white frozen surface also acts as a blanket that insulates the ocean below from the atmosphere above. On the other hand, when the sun shines on an open ocean, those seas warm. So when the sun shines on an open ocean, all that energy is absorbed and the seas warm. And when those seas warm, this causes the neighboring ice floes to melt. As those ice floes melt, this leads to more open ocean, which leads to more ice melting, which leads to more open ocean, and so on. In the language of science, this is sea ice albedo feedback. Albedo being a measure of whiteness. It's like this. Imagine you're a parent dressing your child to send them out to play on a hot summer day. What t-shirt are you going to put on them? Are you going to give them the white t-shirt? Or are you going to put on the black t-shirt? So that frozen surface of the Arctic Ocean, that's our planet's white t-shirt. The frozen surface of the Arctic Ocean is part of a unique cooling system. It's part of a unique system that has kept our Earth cool through the ages. So let's go back to our 3 snapshots in time. The changes that I saw in 2017 were ones that I could never have foreseen. And yet it turns out that through my experiences, I've been a witness to the greatest environmental transformation of our time. No other environment on Earth has changed as rapidly as the Arctic Ocean has. No other environment has lost 3/4 of its solid mass in scarcely 4 decades. That's right. The Arctic Ocean has lost 3/4 of its sea ice volume in that short space of time. This transformation, this shrinkage in sea ice volume in the Arctic Ocean, this means that the Arctic Ocean is rapidly shifting from being a key component of our Earth's cooling system to actually be part of its heating system. Think about that for a moment. The impact of that transformation is like the flick of a light switch. When sea ice melts, the change in color, the change in albedo, it's immediate. This is not the slow, steady creep of sea level rise. The ocean is either white and reflecting the sun's energy back to space, or it's dark and it's absorbing that sun's energy into its depths. And yet few, apart from climate scientists and polar oceanographers, are familiar with the fundamental role of Arctic sea ice in regulating global climate. So I'm imagining this scene out of Star Trek. You know, I'm standing in the control room of the Starship Enterprise, right? The ship is under attack, and those deflector shields are all we've got. It's kind of like that for us as passengers on Spaceship Earth. Our ship is under bombardment by the sun. and our great deflector shield, the sea ice cover of the Arctic Ocean, is weakening. We have to get that deflector shield back up, which is actually something we can do. Climate science tells us that sea ice will return once greenhouse gas levels in the atmosphere are lowered. I know what you're thinking. An impossible task. Let's think about that one for a moment. When humans first discovered how to make fire, could any of them have imagined a world like the one we live in today? We're just getting going on renewable energy and viable alternatives to the burning of fossil fuels. In the context of those humans and that first fire, renewable energy today is primitive technology. I can only imagine that once humanity puts its mind to it, we can create a new energy paradigm that will set up the conditions for Arctic sea ice cover to be restored. But in order to do that, we need to take the emphasis off of the individual, what the individual is doing or hasn't been doing, and we need to put the focus on the structural changes that society needs to make, with all of us working together as a whole. We need to do this. We have to do this. We can do this. Arctic sea ice is a fundamental part of a habitable planet.